And you can see the mean and the standard deviation we found yesterday. Remember that? All right, so let's play with a new, little bit of a different scenario. So, decided though I'm going to give you a raise. To make a decision about the raise, we're going to complete the tables below and calculate the new mean and the new standard deviation just using our calculator. So, option 1 is to add $10 per hour to each of those slips of paper. So if I do that, my new wage here would be what? 11. This would be 15, 17, 21, 25, and 35?
20.
Oh, math is hard. 20. Thank you. Why do I have $11 in my head? Yes. If I do, it's right there in that stack. All right. Now the probabilities won't change. It's just the value of the wages. So the probabilities, we're just going to copy those straight down. There's still same amount in the bag of each. You find them? Just do it on a separate sheet of paper. You can add it to yours later. Did you lose the whole thing? Or just don't know where it is right now? Okay. All right, so let's go back to our calculators. Maybe your stuff's still in there. Let's see if mine is. In the list. Yeah, stuff's still in there. Probabilities are in there, values are in there. So now I'm going to find my mean and my standard deviation, I'm just going to change list 1, right? I'm going to add $10 to each. So that's 11. And recalculate. Remember, I'll go to stat, calc, one variable statistics, and I want to make sure I have L2 under frequency list. And my new mean is $18.40. My new standard deviation is 4.76. That good? Did y'all get that in your calculators? Did you change the L1 line or L1? All of those correctly? 11. 7. Yeah?
Did I do it wrong?
Something's not right. Let's go back.
Isn't the mean supposed to just be like added 10?
Yep. Oh, that should be 7 out of 30. That's why it's typed wrong.
Oh.
10 out of 30. That's right. 3 out of 30. And then 1 out of 30. Try it now. That's what it was. Okay. So notice what happened. We added a constant, right? We added $10. That's my constant. Adding a constant was adding a value. What did it do to the mean? It literally just added, nope. It added $10 to the mean. So now it's $18.40 on average, which is a pretty good hourly wage, I would say, for y'all's age. What about the standard deviation? Did it change?
No.
No. Adding did not change our standard deviation. Now, option 2, double the wage of all the employees. So I'm doubling. So I'm going back to this. So if I double it, I have what? 2, 10, 14, 20, 30, 50. Probabilities are not changing. So let's enter that in our calculator to see how does it adjust our means and standard deviation. That's not right. Oop. Now my mean is $16.80. Standard deviation is now 9.52. Right? So this time we multiplied by a constant, also known as doubling it, right? Multiplied by 2. How did that affect our mean, the original mean? Exactly, just multiplied by 2. Because the original was $8.40 times 2 gives me $16.80, which is my new mean. What about the standard deviation? Did it get affected this time? Yes. So both the mean and the standard deviation by 2. So that was 476 times 2 gives me 952. All right? Does this ring a bell from chapter 2? We talked about what things change means and what change standard deviations. Adding or subtracting constants change the mean, but they do not change standard deviation. Multiplying or dividing by a value will change both. All right, so which option would you prefer and why? Which option of the raise would you prefer? A, because why?
Because overall they all got $2 more, and the lowest isn't $2, it's 11.
Yeah, on average it's higher, right? But what if like you originally had 25 an hour and you went down to 14? That one person, you already don't like them, so whatever, right? So yeah, probably option A. On average, everyone will get a higher wage. And it has a lower standard deviation. So if it's different, it's not almost $10 different here. Look at that. A $10 difference is huge, right, when it comes to wages? So less variation, higher average. Makes more sense. Yeah, are we good? All right, so adding and subtracting. This is just recapping what we just did, and honestly, it's recapping chapter 2. Do you remember this? If we add or subtract the constant, does it change the shape? How does it change? It does change the shape? Is that what you said? No change. Constant C. So we're calling C the variable, but it's just whatever we're adding and subtracting, okay? The center, does it change? Yeah, so I would take the mean and I would add or subtract that value of whatever C is. Will the variability change? No change. What about multiplying it? Will the shape change? Nope. That's the nice thing. Neither one of them change our shape. No change in the shape, but will the center change? Yes, it'll be mu times c or mu divided by c, whatever c is. It could be dividing, it could be multiplying. The mean will change for sure. Variability, standard deviation? Yeah, same thing. Standard deviation times c, or if it's dividing, it's the standard deviation divided by whatever that value is. C. Could you have combinations? Sometimes you will see one here in a second, where they put adding and multiplying in the scenario, and you just have to be aware of which ones apply to which values, right? So let's look at this. X is the number of billionaires in a recently selected state. Based on current records, the probability distribution is as follows. The random variable X has a mean 12.68, that's millionaires or billionaires in a state. Standard deviation of 29.02. Suppose a law is passed requiring each billionaire to pay $1 million to their state. Let Y equal the money received by a randomly selected state. All right. So consider the graph of the population or probability distribution of X and a separate graph of the probability distribution of Y. What do their shapes look like? Think about billionaires in the state. Is it equally likely everyone's a billionaire? That would be a uniform distribution. Is it like that? Right skewed? Why do you say right skewed?
Because there's very few people in the state that are billionaires, so it would go down.
Yep, I would agree. Right skewed. So the number of billionaires is going to be pretty low in that state. Right? Does that make sense? Pretty low. So like, you're not going to have 100 billionaires. You might have, like, on average, 26, right? So that average is going to be closer to a lower number. That's what we're saying. All right. Find the mean of Y. Find the mean of Y. Y is how much money is the state going to receive, right? So what does it say? Money received by a randomly selected state. What do we know about the money they're going to get? The mu of Y would be what's the average amount of money they're going to get? Well, on average, how many billionaires in the state? 12.68, right? And each of those millionaires has to pay the state how much? $1 million. So how much is that going to translate to? 2, 6. Oops. Yep, I forgot a 0. So on average, that's what the state is going to get, right? Because it's multiplying, isn't it? It's multiplying, okay. Calculate and interpret the standard deviation, all right? The standard deviation of Y would be, the original standard deviation, they told us is 29.02 times 1 million. So 29 million. Okay, let's interpret the amount of money received by a randomly selected state Remember standard deviation, that key phrase, it typically varies by about. By 29.02 million from the mean, which was did I do that wrong? Let's see. That's a big standard deviation, isn't it? All right. Now moving on. It says each state agrees to invest $500,000 in roads to improve the roads. Therefore, the net value of the money is now, look at this equation they're giving us. It's now y, which is what we calculated up here, right? Minus the 500,000. Describe the shape, the mean, and the standard deviation of this new distribution. So, the shape of n, remember the original was right skewed. What's the shape of this one going to be? Right skewed. It's not changing. It's just moving down the x-axis, basically. It's just shifting down. So it's still right skewed. No change. The mean, mu of n, would be what? Yep. 12, 6, 8, 0, 1, 2, 3, minus 500,000. It's a lot of zeros on a Friday. So 180. 12,180,000. What about the standard deviation of n? No change because we're just subtracting, okay? So the sigma of n is equal to the sigma of y. No changes there, and that was 29. Okay. Ring a bell? Not really new information to you. We're just bringing it back. Okay.